guys, today's question is the rate of exchange of cyanide ligand in the complex says tetracyano nickel 2 minus and hexacyano magnesium 3 minus, and the third is hexacyano chromium 3 minus by CN14 complexes follows the order. अभी rate of exchange of cyanide ligand से हमें CN14 से कौन जल्दी exchange कर पाता है ये निकालना है उसका rate. So first of all we are given the square planar complexes, that is nickel का है और magnesium का octahedral है, chromium का भी octahedral है. As compared to octahedral complexes, this is the square planar complex nickel which has the geometry sp2 hybridization and the geometry is square planar complex square planar है, और ये octahedral और chromium भी octahedral है. तो इनका ऑक्सीडेशन देखेंगे, ऑक्सीडेशन स्टेट अगर कैलकुलेट करेंगे तो निकल का आएगा x इक्वल टू +2, मैग्नीशियम का ऑक्सीडेशन स्टेट आएगा +3 और क्रोमियम का ऑक्सीडेशन स्टेट आएगा +3. These are the oxidation state of the given complexes. Here what we have so हमें exchange rate कैलकुलेट करना है, तो इसीलिए as compared to octahedral square planar will be more efficient for the exchange rate of cyanide for exchange by CN14. Okay, now what we know that the cyanide is a strong ligand and it is present in the all three complexes, so that it will pair 3d orbital. It will pair the 3d orbital strongly, as well as in this also 3d orbital is completely filled, and in this also the 3d orbital will be completely filled by the strong ligand cyanide. So here the strong ligand and the square planar, as compared to square planar complexes, octahedral complexes, the square planar will be more easily exchange the rate by CN14. So the order of these complexes will be first that is square planar will be greater than second complex, that is Mn wala, उसके बाद chromium wala third complex. In this way the order will be like this. So in this we have we know that the nickel is D10 and magnesium is D7 and the D6 is chromium is D6. So Mn has more D electron than chromium. So this is the explanation for this questions. Now what happened here? Here the nickel has electronic configuration, that is argon 3d8 4s2, and we have calculated the oxidation state, that is +2. So here the +2 and the 4s2 will be subtracted. So what we get 3d8 4s0, and because of the cyanide is a very strong ligand, so that it will tries to pair in the 3d orbital. So this electron moves towards this orbital to get paired. Okay, so what here we get now what happened, the cyanide ligand is given, that is 4 ligand, so it will tries to pair like this in these 4 orbitals. So this is the 1 2 3 4, that is d का 1 orbital, s का 1 orbital and p का 2 orbital. So this found to be dsp2 hybridization. Okay, now what happened, magnesium complexes, here we have calculated the oxidation state is +3. So the 4s2 and d का 1 electron and 4s2 के 2 electron मिलके this oxidation state को न्यूट्रलाइज करेंगे, तो यहाँ पे 4s0 आएगा और 3d4 आएगा, 3d4 4s0. Now what happened here, and because of strong ligand of the cyanide, it will tries to pair in the 3d orbital. So the 1 electron from this orbital jump into first orbital to get paired. So here we got such a now excitation of the electron takes place. Now the second the ligand cyanide minus, it will tries to pair, comes in such orbitals of the 3d in the this is the 6, this is nothing but the 6 ligand of the cyanide, so it will tries to pair in 1 2 3 4 5 6. So 1 2 3 4 5 and this is 6, means the geometry is comes to be d2sp3 hybridization. Okay, so this is for the magnesium complex. Now for the chromium complex, here is also the octahedral complex and the 6 ligands are present. The oxidation state is +3, and here is also the +3 oxidation state is neutralized by 4s, 1 electron of the 4s and the 2 electron of the d orbital, so that this will become 3d4 4s0. So chromium for +3 oxidation state, the 3d5 4s1, here the oxidation state is calculated is +3 oxidation state. So we have taken the 1 electron for s orbital and 2 electron from the d orbitals, that is we have shown here d2 4s1 ऐसे फिर 3 electron को subtract करना है +3 oxidation state से, so it will becomes 3d3 and 4s0. Here we have written it like this, so that now the 6 cyanide will try to pair in the orbital of 3d first, that is d2, and we get such a geometry like this, that is 1, this is 2, this is 3 4 5 and 6. So that we got the such a d2sp3 geometry of these complexes, and this found to be dsp2. This is the dsp2, this is d2sp3, this is also d2sp3, this is the octahedral ligands, and this is the octahedral complexes, and this is the square planar complexes. So that the square planar complexes will the rate of this complex will be fast exchanged by the CN14 complexes, so that the order of these complexes will be first. So the first will be greater than second and then the third. So thank you.